Hello, welcome back to Mars. I'm Mick, we're playing Stationeers. Now today we are back at our programming workstation today, and today we're going to have a look at arrays. Now for people who don't know, an array is just basically a table of data, or a list of values, just constants, or you can make them variables if you want. It's just a sorted list there which you can just access certain parts of it as you need, whenever you like. Just a handy way of storing variables without actually having to name every single one of them. There's two ways we can do that. Well, two ways that I know of. They may not necessarily be the only ways to do it, but the two we'll cover here today. Now, the first one we're going to cover is just using your registers. Now, bearing in mind this is only good for short lists there because you've only got 16 registers to play with. But we can do it with registers using indirect addressing. So let's have a bit of a look. So what I've got set up here is a display and a dial. Now at the start I've just set assigned values to all of my registers R0 through R9. They'll be our 10 values that we're storing: 5, 14, 6, 22, 98, 47, 38, 2, 72, 1. There, that's our array. Just a series of numbers there, just numbers I've just pulled out of nowhere. They don't really mean anything, they're just an example. Our code is very short and sweet. So we just load from the dial our setting. I've stored into R10 because I've used R1 as one of my variable numbers here. Now we've deliberately used them from 0 to 9 because I'm reading a value from a dial which will be from 0 to 9. Because to access those ones, I'm going to use the dial setting. So instead of using our registers being labelled R0, R1, R2, etc., we're going to use the value from the dial to specify that number there, and it will be an indirect addressing. So we're not directly calling it, we're calling an address via another variable. So we are reading that value from the dial and storing it R10. Then our simple code to call it back, as we're saving it to the display setting, and to call back one of these values, we're calling an R10. So the register specified by R10. So that's how we've done it. The register we're going to be looking at will be specified. 0 through 9 will be the value that comes out of R10. So a double R10. So it's an indirect addressing register using R10 as the value. So if I confirm that, everybody's remembered those numbers? Good. So if I confirm that and export it, we've got it running here. So we've got it set on 2, which was R6, as we all remember quite clearly. 3 was 22, 4 was 98, 5 was 47. So just using those couple of lines of code, we now have access to all those numbers there. Very simple. But once again, you are limited by the number of registers you have, so that pretty much cuts you down. Another way of doing it is actually by using the stack. Right, now if you haven't seen my last video on the stack, have a look at that one there because that'll give you all the precursor from what we're about to do here now. So last time I said not to mess with the SP because SP is the marker at the start of the stack. So as when you place values into the stack, it will use that to determine what's going in there. So we've got a value in there, we can peek at it, which is 5. I can push another one in there as 8. And we see SP increases. The stack pointer is just a pointer to the end of the stack there. Once again, I can peek at it. I can pop it back out again. 8 comes out. 1 left. 5 is still at the top of it. I can pop that out. And the stack is now empty. Now, the SP is the pointer to the top of the stack. If you mess with that, the program will lose track of where the top of the stack goes. That's okay if you want to use the stack the way it was intended to be used, but very early on when I started this channel I said don't build a furnace inside your base. And here's a furnace inside my base. Well, we do it again. I say don't mess with SP. So let's mess with SP and see what happens. Last time we said that the stack was like a deck of cards face up on the table. Well, that's a good way of visualizing the stack as it was meant to be used. But in reality, it's a digital space in a computer. So it is not a stack of cards. You do not actually remove things or add things to it. It's a set space in the memory there. So think of it more as a heap of letterboxes or pigeonholes or whatever you want to call them there. And you don't actually put things in it, you copy things into it. When you take them out, you copy things out of it again. Nothing actually goes in or out, it gets copied. So this is a fixed amount of memory which is set aside for storing values. It doesn't change, it stays there the whole time. You'll copy over it. When you push something in, you copy something from a register into the stack. The old value still stays in the register until you reuse that register, and then it changes. The same as for the stack. So if we add 8 into it, right, we know 8's in there because we can peek at it, not a problem. If we add more into there, let's add a 14, push it in there, right, we can peek at it, it's still there. Now, if we pop that back out again, the 14's gone, we can't access it anymore. We can peek at the next one at the top, which is still our 8. But what has actually happened to that 14? The next item in the stack there, where's it gone? What has the computer done with it? Well, the computer, in its attempt to be as fast as possible, it eliminates all unnecessary activities. So what has it done to it? Well, absolutely nothing. All it's done is change the pointer to say that old value is no longer the top of the stack. The top of the stack is now 5. So if I put in a bit of extra code, I put an add button in there, and once again we just check when the add button is pushed. When the add button is pushed, all I do is add one to the stack pointer. I do not push anything, I do not pop anything. I'm just changing the stack pointer now. Right, so our extra button down here. Right, we've still got the same stack there. We reset it, we haven't done anything. So we've still got our peak. It's still 8 as the top of the stack. I can now use the add button. I have just increased the stack pointer now. So now if I peek at the top of the stack, our 14 is still there. It hasn't gone anywhere at all. And once again, if I push in more values, it'll carry on as if we never actually popped that value out. Push it in, 9, push it in, there we go. We can still peek at them, it's 9, I can still pop out that 9, peek, we're now 16, I can pop out the 16. So our stack point is now back to 2. Once again, if I add and peek, the 16 is still there. Add again, the 9 is still there as well. So all the values we've put in there aren't being deleted. So this will allow us to push a whole array of items into the stack now, far more than the 16 which we're limited to with the registers. And just by changing our stack pointer, we will be able to retrieve any of those values as we want. So let's give it a go, shall we? Alright, so here we are back with our first example again, except this time, instead of moving them into registers, we've just pushed the exact same set of values to the stack. Now notice this is outside of our main loop. We only need to do this once because we're just storing all of our values straight into the stack. We don't need to repeatedly do that. Now into our main loop, what we're doing is we're reading SP from the dial. So whatever dial setting is, we're overwriting SP. Now when you're reading from the stack, you don't want a 0 value. So for the sake of this one, we're just adding 1 to it. So instead of the dial reading from 0 to 9, it's now reading from 1 to 10. And then we're peaking, we're do a peek of the value of SP and assigning it to R0, then displaying it. So there we go, that short bit of code can access those based on the dial we've got there. So confirm that one, export it. So just as we change our dial now, we're getting all the values out of the stack. Once again, they're staying there as long as I don't try and write anything else to the stack now, because the stack pointer is set somewhere in the middle of that array. When I try and push something to the stack will quite happily say, yeah, that's the top of the stack, I'll just write over whatever's there. So just be careful using this when you're still pushing and popping other values. Now, so this one is reading. It's just peeking at the value, whatever's there in the stack. So very simple. Now you can store a massive amount of numbers in here, and you've got them all coming out with a very short, very simple piece of code. All you're doing, setting your stack pointer, peeking it, and you've got it. It's there. Done that simple. So I mean, this is an example of sort of something simple. They're just meaningless numbers. I mean, you could do something a bit more useful perhaps. Like, how about a couple of prefab hashes for alloys? Instead of putting them to display, let's also save them to the DB housing. Because I've got a display hooked up to that one. So export that. Oh, look out. If I get there so we can see it. That's now pulling out all of our alloys. That's fine for a nice little display, but maybe we could do a bit better than that. Now this one, if you'll bear with me, the people who know it all, this is just a one-dimensional array. So it is a straight list of numbers. But you can actually produce multi-dimensional arrays. Well, we can simulate the performance of that. Now, a multi-dimensional array will have a list of values such as alloys, and you can also put other information with them as well in other fields. So as well as just having the prefab hash, we could put, say, the melting temperatures, the required temperatures for smelting them as the temperatures and pressures. I'm sure nobody would want me to show you how to do that, would you? What's that? My viewer retention just went up 1000%. Maybe you do. All right. So we can't actually produce a multi-dimensional array, but we can just group these into groups of 3 and just do a bit of math to try and get the same thing to happen there. So let's chuck some temperatures and pressures into these and see how we go. Okay, so here's our new list. Now these are all our hash values for an alloy, and minimum, maximum temperatures, minimum, maximum pressure. So again, prefab hash, minimum, maximum temps, minimum, maximum pressures. Just this grouping just continues over and over again. So this is our main field. These are the elements of each of that field. So each group of 5 is a record within the table. So this is now a 2-dimensional array. So we've got records by 5 columns. Well, basically enough, that's what we've got there. So there's our alloys, minimum and maximum temperatures. So they are all still in a single list. So how to retrieve them? So, well, here's our code. Right, so we load our stack pointer from the dial, same as before. We don't want a 0 value, same as before, we add 1. Now these are in groups of 5, so we're going to multiply it by 5. So our 0 setting becomes the first setting, 1, and we multiply it by 5, which goes to 5. Now 5 will take it to the end of the record, which is our maximum pressure. So now we can just pop them out. Pop, 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 pop. There's our 5 values coming out. Of course, when we're popping them, it doesn't actually remove the value, it just copies it out and reduces the stack pointer. So we don't need to adjust SP, we can just pop the next value again. So from there, we are once again in the reverse order. We're popping them out, so from the end out. So we are popping out our max pressure, which is our last reading, then our minimum pressure, then our maximum temp, minimum temp, and eventually the prefab hash, which we're saving to the DB housing. So if we confirm that, export it, oops, switch it on, might help. No errors, we're good. So we put it out. We have our alloy maximum minimum temperatures. Decrease. Astraloy. Decrease. There we go. We've got them all with our temperatures, maximum minimum values. As electrons, our low one there, low pressure, and we should have our solder, which is our low temperature one. So there we go. So now, a single click of a switch, we not only have approximate minimum values, we can have a full range. We can specify the single dial what the maximum and minimum values have to be. So now you don't have to perfectly have your furnace sitting on one value. You can tell your furnace now anywhere between that is fine. And I don't have to have a heap of switches to specify all them. I don't have to remember them and manually set them. It's a single dial now. Boom, all that information is coming straight out of our machine. And of course, you can go further than that if you want. I've just got 5 dimensions in there, but our alloys take certain ingredients. You could put extra fields in there to specify prefab hashes for all the ingredients, and then use those from the record to pull those ingredients out of a vending machine or something like that. I won't go there, I'll leave that for you to have a bit of fun. Right, but another thing you may say, if I hook all of them in, I mean, I've only got all the alloys in here, I don't have any of the basic ingots in there as well. But I've used 55 lines of my precious 128 lines of code. So just in setting the thing up, that's before I start writing the code. What happens if I have a ridiculously complicated furnace that uses every single line of code? I can't afford to be doing that, setting up a stack. That's just not right. I'll have to put this on a separate chip. Then I've got to find enough pins to pass all those four or five values back into the main thing. That's not going to work. Well, before your mind's blown, hold on to your hat, because there's something we can do about that as well. Well, the thing we can do about the stack is persistent. So we can now that we've programmed it all in there, I can now remove this code, because that stack stays in the chip until I overwrite it. So if I now want to change that, I'll take out all these push commands and just keep the bit of code at the bottom. We should still be able to access the stack. So quick edit, and there we have it. We have now removed all of that. All the push items are gone. Export. We still have all the information here. All good. That's not written in there. We've now got all the lines of code we need to use. But bear in mind, it does go with the chip. So if you remove the chip, put in another one, we export exactly the same code, nothing happens because this chip has not had the stack programmed in it. If I take that one out, put the original one back in again, all the information's back. So the stack sits in the chip. Now once the stack is programmed, it remains in the chip. So you can then rewrite it. So if you load a program to set up all the values you want in a stack, then load a furnace control program, you can then access all that information. So now it is just a single dial to access all the information that we programmed into the stack there. So we have maximum, minimum temperatures, prefab hashes, everything we need to run the furnace, and I'm only using up one input to get all of that information. So there's a big saver for you on space, big saver on pins. You probably, well, even though you've got to program a chip twice, it'll save you, remove a chip from your setup. But there we go, mind blown. So as I say, you can also use this to then dispense ingots out of an automatic or dispenser to fill up your furnace. You can program everything you need for a fully automated furnace into the stack. Right, so let's call that mind blown. So that's arrays. So once again we have our 5 field array on this one. It's a 2-dimensional array with 5 fields in each array, each record. Once again, if you add more to it, just multiply it by a bigger number. If you get 10 fields in each record, just multiply by 10. You don't want your 0 value, so add 1, multiply by the number of records in the field, and just pop them all out. Once again, you're popping them out in the reverse order, or you can just peek them and manually change each SP between each one. There's more than one way to skin a cat there. But yeah, that'll probably do us for today. Hands up who's going to rewrite their furnace code now. Anyway, that'll do us for today. So, till next time, happy building. See ya. That's just getting out of control now. Now that's just creepy.